Hello everyone, in this video I will show you how to model an ideal diode and plot its characteristics in LTspice. So if you go to the help section of LTspice and look up diode, you get this page, and here you have all the parameters to define a diode characteristics in LTspice environment. So I have named the ideal diode as ideal diode, and I have this R on set as 1 pico ohm. So R on is the resistance in the forward conduction. Obviously, it should be 0, but I have kept it 1 pico ohm for some reason. I will tell you later. R off is the resistance when diode is off. You can imagine that for ideal diode it should be infinity. So I have kept it to a high value 10 meg. Uh, V forward is the forward voltage drop, which is 0. See, this is the IL diode characteristics, and when it's forward bias, it turns on instantaneously at 0 volt, and it acts as an ideal conductor. And when it's reverse bias, it acts as a perfect insulator that it does not allow any current to flow. So here are some other parameter, reverse breakdown voltage. So obviously I have kept it to inf I, by default it's infinity, but I have kept it to a high value of 1 meg. I limit is the forward current limit. Ideal diode should carry infinite current, but I have set it to a very high value of 1000 ohm to show you the simulation. If I set it to infinity, it will dissolution of this graph will be poor in on the y-axis. So I have kept it to 1000 amp. You can set it to the value you desire. R reverse is the breakdown impedance. Again, you can set it to a high value. I have kept it 10 meg. Reverse current limit. So I have kept it 0 because ideal diode does not allow any current in the reverse bias condition. And this epsilon and reverse epsilon, I have set it as x. Uh, these two parameters are used to smoothen the transition between off and on condition. I will show you through the simulation what does it mean. So let me just run the simulation for epsilon value 0. You see, I get this characteristics curve. It's very similar to a ideal diode characteristic. At 0 volt, it turns on instantaneously and it hits the limit of 1 kilo amp, which I have set in my syntax. In the reverse direction, that is when the voltage is below 0 volt, I have current uh, 0. So this perfectly emulates a ideal diode behavior. Obviously, there is some slight deviation. It's because I have not used infinity impedance or infinite current limit and so on. But yeah, you can get the idea from this how to model ideal diode. So why did I set it to 1 pico ohm, this R on, instead of 0 ohm? The reason is if you set it to 0, for some reason LTspice does not recognize it to be 0, and your characteristic will deviate from ideal diode characteristics. Let me just show you. I don't know if it's a bug or this is how it's supposed to be, but if you keep it 0, uh, for ideal diode should be 0, but if you do it, you see, you no longer get a ideal diode behavior. So just keep it to lowest possible value and not 0, slightly higher than 0, and you will get your ideal diode characteristic. Now let me show you the effect of this parameter x. So I will plot the same curve for two different value of x, three different value of x, 0, 1, and 2. So this green is already for x is equal to 0, and you see, and this blue is for x is equal to 1, and this red one is for x is equal to 2. So what these two parameter does, it just make the transition from off to on very smooth. So instead of getting a sharp turn on, you get a parabolic smooth turn on. And this slope will decrease if you keep on increasing the value of x. So in a way you can use this parameter to as a sort of curve fitting to emulate a particular diode from the data sheet you desire. So I hope this is useful to you in some way. That's all.